Hello, today we'd like to talk about the topic of blood supply of the Gehirn. The Gehirn is made up of 4 large arteries with blood supply, right and left internal carotid arteries, and right and left vertebral arteries. And these drainage areas, these 4 arteries, are connected by a large anastomosis circle. And this circle is called the Circulus Arteriosus Cerebri, or Velici. And here we can have a better look at the picture. In front of us, only 2 arteries are important. The internal carotid artery here, and then the other is called the vertebral artery here. Come on, I'm there. Here is another better picture and the illustration of the arteries of the Gehirn by Basler. In front of us, some arteries are more important than others. Large Haynes arteries, small Haynes arteries. Let's start again. Drainage area of the internal carotid artery. Number 1 here. Internal carotid artery. Here is the internal carotid artery. Then there is the first branch. That's what number 2 means. The first branches come here. These are a little bigger. Anterior cerebral artery. Here from here. The first is the anterior cerebral artery. Then there's another artery, the cerebri media, right here. The area of the internal carotid artery. There are large branches. The artery and the other cerebri media come. Then there's another artery here. It's not as big as the other 2 branches. It's called acoiloidal anterior. These are the important arteries of the area of the internal carotid artery. Now the area of the vertebral artery, starting with number 6. From here we have 2 vertebral arteries. Yes, left and right. The vertebral artery comes from below, from the branch which is cerebellus. Number 8 is, what's number 8? Inferior posterior cerebellar artery. And why inferior posterior cerebellar artery? This artery goes down. That's why it's called the inferior artery. It goes down here. From the back. Then it comes here. That's why it's called the inferior posterior cerebellar artery. It goes down. The inferior artery, then from the back, from the cerebelli, so posterior, and then cerebelli. This vertebral artery continues. Then comes the other branch, that is the inferior anterior cerebellar artery. Why the vertebral artery goes down, that is anteriorly, but now from the bottom side. This is the cerebellum. That's why it's called the inferior anterior cerebellar artery. Then these arteries from the left and right, they will meet each other, and then together they form another artery. This is called the basilar artery. There's only one. This consists of the left and right sides of the vertebral arteries. They form the basilar artery, and from the basilar artery come other branches. For us, some branches are more important. Number 12 and number 13. What does number 12 mean? Number 12 are some branches, and also what's more important for us is number 13, the superior cerebellar artery. Now you can better understand why it's called that. The superior cerebellar artery, because that's from above. This is responsible for the upper side of the cerebellum. That's why it's called the superior artery. The other one, which is also important, but this is not responsible for the cerebellum, but for the cerebrum. This is called the posterior cerebral artery, number 14, cerebral arteries, and here there is a nerve. What is this nerve called? This nerve here, this is the cochlear nerve. Number 4, here is an important nerve. This nerve is called, oculomotor. Number 3, this nerve is between the superior cerebellar artery and number 14, the posterior cerebral artery. These were the most important ones. 3 están a cargo de las arterias grandes y otras 3 están a cargo de las arterias pequeñas. ¿Cuáles son las 3 arterias importantes antes de las arterias pequeñas? De aquí salen 3 ramas que están sueltas y bajan. Son responsables de las partes inferiores del cerebelo. Por eso se llama arteria inferior y una para la arteria posterior. Por esto se llama arteria posterior inferior. Por eso se llama cerebelo anterior inferior. Y la otra se llama arteria superior. Estas eran para las arterias pequeñas. Hay otras arterias que vienen por la arteria la cáutica interna y luego una se ramifica hacia la anterior, por esto la arteria se llama cerebri anterior. La otra se llama arteria cerebral mediana y también hay otra arteria aquí, aunque esa viene de la arteria vertebral, es decir, la arteria cerebral posterior. La arteria cerebral posterior. Ahora quisiéramos describir un poco las otras arterias también. Las enseñanzas pueden ayudar a comprender mejor esto y conocer un poco las estructuras. Aquí la arteria caucásica interna número 1, luego está la arteria cerebral anterior, luego está la arteria cerebral media, pero también hay otra rama llamada aquí está la arteria, es decir, la arteria comunicante anterior. ¿Por qué se le llama a esta comunicante? Porque estas 2 arterias cerebrales anteriores, de la izquierda y de la derecha, van juntas, están conectadas con esta arteria comunicante anterior. Luego la número 5, arteria poloidal anterior, que también es una rama de la arteria caucásica interna. Ahora las áreas actuales de la arteria vertebral número 6, la arteria vertebral del lado izquierdo y del lado derecho, y luego también tenemos una arteria vertebral anterior, que es el cuerno posterior, y este es el cuerno anterior, es decir, la arteria espinal anterior, y luego aquí la número 8, la arteria posterior cerebri, y luego el número 9, la arteria inferior anterior cerebri. Entonces este lado derecho y lado izquierdo de las arterias vertebrales se conectan entre sí y forman juntos la arteria basilar, y desde la arteria basilar hay una pequeña rama que se llama la arteria labirinti hasta el oído interno, luego con algunas ramas hasta el pulso aquí, y luego aquí el número 13, arteria superior cerebri y la arteria cerebri posterior. Esto es importante, aunque eso es responsable de la arteria grande, pero eso viene de la arteria vertebral. Luego el número, también hay otra rama de la arteria cerebri posterior, el número 15 aquí, y otra importante que se llama arteria comunicativa. Arteria comunicante aquí, ¿por qué comunicante posterior? Porque conecta la arteria vertebral con la arteria carótida interna, y luego estas son de nuevo las arterias de la pequeña a la izquierda, pero desde el lado lateral, desde la izquierda. Y lo que también es importante aquí, podemos acceder al nervio. También note, como dije antes, que aquí está la arteria superior cerebri, la arteria cerebri posterior, pero aquí el nervio se llama nervus oculomotorius, que está entre la arteria cerebri posterior y la arteria superior cerebelli, y aquí otro nervio que se llama el abducens número 6, que también está casi entre las arterias. Arteria superior cerebelli y arteria inferior posterior cerebelli, y el nervio trigeminus también es la rama de la arteria pontis, está cerca. Para entender mejor los detalles me gustaría ampliar esta página aquí de nuevo, por eso aquí esta es la arteria basilaris, y de la arteria basilaris estaban las dos ramas importantes, arteria superior cerebelli and posterior cerebral artery. And afterward, from here, this was the internal carotid artery. From the internal carotid artery were also two important branches, anterior cerebral artery and middle cerebral artery. And the nerves, here was nerve number 3, oculomotor. And here is the optic nerve. And here is the chiasm. Here's the hippocampus. And what was also important for us was the anterior communicating artery. Then we can use other branches as well, but these are not so important to us. We only know a little bit. Again, the skull anatomy here, for example, is the clivus, and here, for example, the ophthalmic nerve. But we can also here, for example, this is also important for us, the anterior communicating artery, where the hematoneuroanatomy, which connects this anterior cerebral artery with the internal carotid artery. Now we can talk about the blood-brain barrier. It's a special barrier between blood and nerve tissue in the brain and spinal cord. It has special properties like a closed capillary endothelial with tight junction. This is the luminal capillary number 1, and these are the endothelial cells which are connected to each other through tight junctions. Then there's the glia limitans membrane from astrocyte processes. It's not a component of the diffusion barrier, but it induces the barrier properties. The basal lamina belongs to the astrocytes and the capillary endothelium commonly. The basement membrane here, which simultaneously belongs to the astrocytes and the capillary endothelium. And why is there a special diffusion barrier? The permeability is 100 times lower than the capillary endothelial in other tissues. Astrocytes barely pass, but still the important stuff. Vital lipophilic substances like glucose, amino acids are closed with specific transports. Lipophilic substances such as drugs or alcohol can reach the brain unhindered. So lipophilic substances like drugs and alcohol can reach the brain without obstruction. Then they can also be actively transported back out. And what's the purpose? Through this, the brain can be protected from neurotoxins and furthermore from fluctuations in the plasma composition, for example, those of noradrenaline or glycine. But the blood-brain barrier doesn't apply to brain areas that require direct communication with the blood, such as neuroendocrine, for example, hyperphilia, or chemosensory, for example, the area post-sema. There isn't any. In summary, where the areas that need direct communication with blood, there is no blood-brain barrier. For instance, the blood-brain barrier doesn't exist in the fluxus ruidus, and the internal carotid artery has 4 parts, or rather, it's an artery, but in different areas. That's why it has different names. Pars cervicalis, first parts, and then here goes the pars petrosa, then the pars cavernosa, and there are the pars cavernosa and the pars cerebralis carotid siphon here. At the end is called the pars cerebralis, and the third parts and fourth parts there is a carotid siphon. Here is the artery again. There are more explanations about it. We can also take a quick look again, but we have almost all the spores about all the important things, but we can briefly talk again about the parts of the internal carotid artery. Number 8, pars petrosa. The pars cervicalis is not in the figure, pars petrosa. Then here comes the number 9, here pars petrosa, then the pars cavernosa, and here is the pars cauticus. And here it is also summarized again. The internal carotid artery comes and it has two important branches. The anterior cerebellar artery, which goes to the frontal and parietal lobes. Then there's another type, the middle cerebellar artery, which is for the frontal, parietal, and temporal lobes. And then the vertebral artery and the left and right vertebral arteries together form the basilar artery. They are responsible for the Klein-Hind trunk spinal cord. And then there's the artery first from the basilar arteries, posterior cerebellar artery, that is responsible for the occipital and temporal lobes. So the temporal lobes get a good supply from all three temporal lobes, receive from the middle and the posterior, and here it has from the posterior artery and the posterior cerebellar artery and internal carotid. These pictures show the supply areas from various views, the lateral views and the middle and horizontal, anterior, for example, the frontal and the cerebellum media, and the temporal lobes. Here is also an important diagram, the artery cerebellum serio, cerebellum median, cerebellum posterior. The artery cerebellum anterior gives some important branches, for example, the artery callus, callus marginal, and the artery paracentralis, and the artery terracunealis, and the artery cerebellum media for the temporal lobes, and the artery cerebellum posterior, palliator occipital, and the artery calcaneus. So what's important here? More importantly, the artery paracentralis is supplied by the artery cerebellum anterior. Callus marginal is also supplied by the artery cerebellum anterior, and here the artery calcaneus is supplied by the artery cerebellum posterior. Here there's also a nice picture that is also good that we know it. Artery cerebellum media comes a branch comes the artery centralis anterior lateralis, and the artery cerebellum media, then artery centralis anterior laterale, and that is responsible for the basal ganglia and the capsula interna, for example, here number 4, nucleus pallidum Putzmann, and the number 7, for example, Chaudatus, number 8, thalamus, and number 9 here, capsula interna, yes, that's called capsula interna. The artery cerebellum media, then artery centralis anterior lateralis, then the basal ganglion, and from the capsula interna.